Hello, everybody, and thank you for today's class. I promised in the past that I will record some video to cover up for the classes that we missed, and it is the first of the series. So it's all about calculations in chemistry, and let's get started. So we have so many objectives to cover, and the first part is to be able to distinguish between molar mass and the atomic mass or molecular mass, and also to calculate the number of moles of a substance. Some of these you've learned, some of them when you were in your secondary school then. So we will also learn how to calculate the number of atoms or molecules in n moles or in a mass of a substance, and to distinguish between the molality, and the solubility of a solution, and to be able to calculate the mass and the mass percent of an element in a compound, to be able to determine the empirical and molecular formulas from the molar masses, from the masses of the constituent elements or the compound, and from the products of a chemical reaction. And also to be able to recognize the balanced chemical equation and show the relationships between the number of moles of the reactants and the number of moles of the product, and to be able to calculate the final concentration after dilution. So as I said, these videos will be coming in series. We cannot cover all this in a single video. So let's go. We'll start by looking at atomic mass, which can also call atomic weight. And atomic mass is just the average mass of all the isotopes of an atom with respect to their abundances. Abundances means how much of that isotope exists compared to other isotopes. And atomic mass is expressed in what we call unified atomic mass unit, or AMU. So what is AMU? AMU stands for Unified Atomic Mass Unit. And to determine that, the scientists, all of them, they agreed on using carbon-12 for the calculation of atomic mass unit, or to determine atomic mass unit. So one atomic mass unit is defined as 1/12 of mass of a single carbon-12 atom. So how do we calculate that? We have that one atomic mass unit, this is 1/12, we said, and then mass of a single carbon-12 atom. So 12 grams divided by N of A. N of A is the Avogadro's number, which is 6.02 times 10 to the power of 23. So we are not using this one in calculation, so you don't need to bother yourself too much. This one is just to determine what AMU is. So this is the calculation that may be needed regarding that part that we just discussed now. Remember, what we discussed is the atomic mass. So I will give you, or I may give you a question like this to determine to calculate the average atomic mass of magnesium. So here we have three isotopes of magnesium, that is magnesium 24, magnesium 25, and magnesium 26. And the abundances of these isotopes are 78.99 for the magnesium 24, 10 for the magnesium 25, and 11.01 for magnesium 26. So we have the atomic masses of each one of them here as well: 23.98, 24.986, and 25.983. So we want to calculate the average atomic mass of magnesium. So this is easy. You must have done something like this in the past, but just for the purpose of revision to those that have done it in the past, and then it's going to be a new knowledge to those that have not done it in the past. So how do we calculate the average atomic mass of an element? Just look at the mass of that element, of that isotope. So we have this, that is the mass. Let's say we want to start with the magnesium 24. We just see Mg 24. That is the mass of magnesium 24. So let me write it. Mass of Mg24 of magnesium 24. I can do it this way, same thing. So this is magnesium 24. Mg24. The way we write for carbon 12, this way. So mass of this magnesium 24 multiply by the percentage abundance of that magnesium 24, which is 78. So I will just write percentage abundance first. So this is for magnesium 24. So you do the same thing for magnesium 25, that is mass of Mg25 times its percentage abundance. Do the same thing for the third one, which is mass of magnesium 26 times its percentage abundance. So you now add each mass. Add your calculation over there to what you get here as well. Add them together. That will give you the average atomic mass of magnesium. So how do we do that? Let's do that quickly. So the mass of magnesium 24 is 23.985. 23.985 times, what is its percentage abundance? That is 78.99%. 78.99 over 100. And then we do the same thing for the second one, which is 24.986 times 70 times 10.00, 10 over 100, and then plus the third one, which is 11.01 times, sorry, I said 11.01, supposed to be the mass, which is 25.983 times 11.01% over 100. So do the calculation and let me know what you get. So for magnesium 24, the answer is 18.945.8, and then for the second one it is 2.4986 atomic mass unit, and the last one is 2.607 atomic mass unit. So that is the calculation for all the three of them. Remember, we are adding them together. So when we add them together, we will get 24.305 atomic mass units, AMU. So this is the final answer. So that is the average atomic mass of magnesium. And that is how you are going to do the calculation if you are given in the exam.